In our last video, we looked at resistors in series and in parallel circuits. We also found ways to actually derive the equivalent resistance both in series and in parallel circuits. Now, in this video, we're going to use those two principles to actually calculate the equivalent resistance within a number of circuits. So we'll start off by asking, what is the total resistance of this circuit right here? Let's take the two resistors to both equal 100 ohms. Now, this symbol is the Greek letter omega and indicates ohms, which is the unit of resistance. All right. So when we are asked to find the total resistance of a circuit, first thing we ask, is it series or parallel? Here we've got two resistors in a single line, so that would be a series. And so to calculate it, we know that the equivalent resistance is just going to be the sum of the two resistances. We know that they're both equal to 100 ohms. So that means that the equivalent resistance is equal to 200 ohms. Pretty simple. Let's do one a little harder. Let's go to a parallel circuit. Same story, we have two resistors that are in parallel with each other. And we know this because the current branches into two separate lines, one going through R1 and one going through R2. To find the total resistance in parallel, that's just 1 over the equivalent resistance, would be 1 over R1 plus 1 over R2. All right, so that's 1 over 100 ohms plus 1 over 100 ohms. That'll be 2 divided by 100 ohms. Now, remember, we could simplify this, that's fine. You could simplify it now or later, it doesn't matter. But simplifies to 1 over 50 ohms. But remember that this is equal to 1 divided by your equivalent resistance. So in order to find the actual equivalent resistance, we have to take the reciprocal on both sides. Here, let me do it this way just so there's no confusion. You have to take the reciprocal on both sides, which of course brings that down to 50 ohms. All right, so that's just one simple series and one simple parallel circuits. Let's go with something a little more complex now. Here you have two resistors which are in parallel with each other, and those two are in series with another one. What do you do here? It's neither series nor parallel, it's a combination. Well, the simplest way to do this is identify the simplest combination you can. So if I combine these two, well, that's the 500's in a parallel circuit, but not with the 400. That doesn't make sense, nor would this make sense. But these two are most definitely in parallel with each other. So we find this resistance here. This would be 1 over 500. Oop, trying to write on a computer. Try it again. So the parallel equation is 1 over the 1 over the resistance equals 1 over R1. Excuse me, I don't know what I just did. I zoomed in apparently. There we go. Plus 1 over the other resistor. Okay, so now we have to find a common factor. Well, if I multiply the first one by 7, then that's 7 over 3,500. And I'll multiply the second one by 5. That gives me a common denominator. You can also do this on your calculator, it's true, but I find that this is, it reduces rounding errors. So you end up with 1 1 over R equaling 12 over 3,500. So your resistance is going to be 3,500 ohms divided by 12. That's going to be just shy of 200. Let me pull out my calculator here. If I can remember where I put my calculator, hang on. Here it is, I found it. It was under a book. 3,500 divided by 12 gives us a resistance of 291.67 ohms. All right, so these two, which are in parallel, have a total resistance of 291.67 ohms. Therefore, we can treat them as if they were just one simple resistor of 291.67 ohms. Now, because of significant figures, we don't know if those were exactly 500, 700, so we're going to just round it to 290. All right, so now you have this combination we just found of 290 ohms, which is now directly in series with the 400 ohm resistor. So that means that my total resistance is going to be in series. We just add them up. So that means my resistance is 690 ohms. All right, let's do one more that's even more complicated. Yeah, there's a lot going on here. You have one that's in parallel with one which is in parallel, which was in series with two that are in parallel. Yeah, it's complicated. Just like we did before, we find the simplest structure. So here we have two resistors that are in parallel with each other. No matter which other resistors you pick, it's going to be more complex. So we're going to start with this one. Since they're in parallel, we know that 1 over R is going to equal 1 over 8 ohms plus 1 over 4 ohms using the parallel equation. So that would be 1 over 8 ohms plus 2 over 8 ohms, or 3 over 8 ohms. But remember, that's 1 over your resistance, so your resistance is going to be 8 ohms over 3, which would be 6 2/3, or 6.67 ohms. 8 divided by 3, checking that on my calculator. Whoa, I did that wrong. It'd be 2 2/3. I apologize, I was getting ahead of myself. So that's 2.67 ohms. All right, so then we redraw this circuit, but we replace the 8 and 4 ohm resistors, which are in parallel with each other, with 2.7 ohms. All right, now we pick the next simplest structure. Well, these two are in series with each other. So that resistance is just going to, since they're in series, just add them up. 6 ohms plus 2.7 ohms would equal 8.7 ohms. I'm getting sloppy with my units. There we go. All right, so now we redraw the circuit, combining those to be 8.7 ohms. Now find the next simplest one. These two are in parallel with each other, and so 1 over your resistance is going to be 1 over 10 ohms plus 1 over 8.7 ohms. Here there's no real common denominator, so I'm just going to do this one as in decimal form. That 1 over 10 is just 0.1 plus 1 divided by 8.7 is going to be 0.1149 ohms. So 1 over your resistance is going to be 0.2149 ohms. And so my resistance is going to be 1 over 0.2149 ohms. Excuse me, I just realized I made a mistake with my units here. These are all 1 over ohms. And that would make this all in ohms. Taking that, my total resistance would be 4.6524 ohms. Significant figures, we're going to round it down to 4. This figure, I got 4.65, which should be 4.7, but the textbook must have had some different rounding formula or whatever. They got 4.8. We'll give them that. All right, now you see that all that's left are 3 resistors all in series with each other. And so now the total resistance is going to be 0.50 ohms plus 4.8 ohms plus 5.0 ohms. So adding all that together, that should give us 10.30 ohms. Double checking on my calculator, making sure I did my math right. 5 plus 4.8 plus 0.5 gives me 10.3. And there you are. So this whole complex circuit here, we took it apart piece by piece and found that the total resistance is about 10.3 ohms. And this is a good, simple procedure to follow whenever you have complex circuits trying to find the total equivalent resistance. And when we get to capacitors, you'll see that we'll follow pretty much the same procedure. Equations will change just slightly, but it is the exact same procedure for capacitors as well.